So I just want to show you a little bit of cryptography. There's quite a lot more, but the password hash is as much as we'll do today. So Microsoft has a really old, now back in the really old days, like I think MS-DOS, and I think maybe Windows 95, although I'm not sure, they actually had this file called the PWL, the password list, that just had your passwords just sitting in there. And people figured out that that's a pretty bad idea because somebody will find that file and get all the passwords. So now they hash them with a supposedly one-way function so that you type in your password, the computer hashes it and saves the hash, and then when you log in, it takes whatever you give it and hashes it and compares the hashes. So what's actually stored in the computer is not your password, it's a hash. And the idea is, even if somebody steals the hash, they cannot determine the password from the hash. Now that is not as true as it should be. But anyway, this is the Windows NT password hashing algorithm invented in 1993 to improve the previous one, the LM hashes, which really were a lot worse. So if you have a password, PASSWRD, the hash is always the same, 8846 followed by this junk. Windows does not insert any random characters or anything, so if two people have the same password, they have exactly the same password hash. So you can, of course, calculate these hashes in Python, just like you can do everything. So let's make a script to do that. If I nano hash1.py. So there's the code. As always, you just import the library, the hash library, and then you can make hashes of any type. And to make a Microsoft password hash, you use MD4. You probably heard of MD5 and SHA-1 and SHA-2, but this is so old. In 1993, when Microsoft wrote this, MD5 had not been invented yet. The most advanced algorithm available at the time was MD4. So you take password, encode it as bytes, and hash it with MD4. Now let's see what happens when you do this. Python 3, hash 1. All right, it created a hash object, and it just shows me the address of the hash object. So this is not what I wanted to see. So I have to at least tell it to do a hex digest of it. That's how I get it back to the hexadecimal value that I'm used to seeing. So don't just print the address of the object, but give me the hex digest part of it, which is the part I care about. So now when I run it, I get a reasonable looking hash, but the problem is it's wrong. The right answer is 8846, and this is 8A9D. There's still something wrong here. And what's wrong is what I mentioned before. Microsoft does not use ASCII. Microsoft, even from 1993, Windows was an international operating system. It's supposed to include Japanese and Arabic and Chinese and Russian script and everything else, so they don't use 8-bit characters. They use 16-bit characters. Now, it would be nice if they used modern Unicode, like Python 3, with up to 4 bytes, with 2 million characters, but they use a really old form of Unicode that only uses 16 bits per character, and it's really wasteful because if you have English, it puts a null byte after each one. Every character is 16 bits long, whether it needs to be or not. But anyway, that's what they use, and that is this encode with UTF-16LE. That is the particular old version of Unicode that Microsoft uses. So I'm just going to replace my code with that, get rid of the old code. So you have to take the plain text password and encode it with 16-bit Unicode, and then run it through MD4, and that is the Microsoft password hashing algorithm. One round of MD4. And now you get the 8846 number you're supposed to get. So you can now calculate Microsoft password hashes, and therefore you can do Microsoft password hash cracking. The way you crack password hashes is you start with a list of passwords, and you just hash them all until you find one that matches the hash you found stored on a machine. That's it. So you can create a password that calculates the 100 hashes for 2-digit passwords from 00 to 99. And there's a flag defined there. And then I made a series of passwords that have just a 2-digit PIN at the end, and the rest of it is fixed. And I went and made accounts for them on a real Windows machine and captured them. On real Windows machines, the passwords are stored like this. You have the name and then some other stuff. And then you have the old LM hash, which is not used anymore, so it does not contain any information. It's always just a fixed value now. And after the colon, this is the new NT hash, which is the MD4. So you have to take this part and find it in a list of 100 possible passwords. And there's a series of increasing difficulty ones here. You could improve your thing to MD5. You could have MD5 and then SHA-1, and you could have many rounds of them, and you gradually move up to modern password hashing algorithms. Microsoft's password hashing algorithm is literally 1,000,000 times weaker than modern operating systems like Linux and the Mac. It is really a sin and a shame that they haven't improved it, but they haven't. And modern machines, here's Linux password hashes that are 1,000,000 times stronger. This is password type 6, and there's even a new one after this now. It adds assault, which is 16 random characters to your password, which is the part between these $signs, so that if two people have the same password, they will not have the same hash. You add 16 random characters to your password and then hash it. And that's what this mess here is. And they don't hash it with 1 round of MD4, they hash it with 5,000 rounds of SHA-512. And that is a whole lot more calculation. And the idea is that if you have a list of 1,000,000 passwords, it's going to take you a really long time to calculate 1,000,000 password hashes. So when I gave my students homework to practice, they find Microsoft hashes in a list of 100 million. And when they go to crack Linux hashes, they only have a list of 100. That makes it possible in a reasonable amount of time. So anyway, these are Linux password hashes. And by the way, the hash is actually much longer. It goes all the way down to here. And then I actually made some LastPass hashes. LastPass is a password manager, and they're proud of being secure. They use 100,000 rounds of SHA-256. So you can crack that with Python too. These are 100,000 round hashes. So anyway, you have a good time cracking those hashes. And let me stop this one.